Good day, everyone. My name is Shivani Rakber. We are examining a case where engineering excellence was overshadowed by executive pressure. Profits overpeopled the ethical failures of the Boeing 737 MAX 8. This presentation will analyze how leadership decisions led to a global crisis and what it reveals about the critical intersection of engineering duties and corporate responsibility. We will specifically focus on the role of Dennis Muhlenberg and the systematic failures that resulted in one of the most significant tragedies in modern aviation history. So this case study serves as a stark reminder of the devastating consequences that occur when engineering ethics are compromised by the pursuit of profits. Our analysis centers on Dennis Muhlenberg. Unlike many executives, Muhlenberg was a trained aerospace engineer and a lifelong Boeing employee. During the crisis, he served as CEO, president, and chairman of the board. This dual identity as both an engineer and a corporate leader meant he had the technical capacity to understand the risks of the MCAS system, yet he oversaw an organizational culture that prioritized speed to market over rigorous safety. This crisis was not just a technical accident, it was a multidimensional failure. Technically, the MCAS system violated basic engineering principles of redundancy by relying on a single angle of attack sensor. Organizationally, Boeing rushed development to compete with the Airbus A320neo and deliberately withheld MCAS information from pilot manuals to avoid expensive training requirements. This combination of technical flaws and corporate secrecy resulted in two catastrophic crashes that claimed 346 lives. The timeline of this crisis began in 2011 when Boeing rushed the 737 MAX design. On October 29, 2018, Lion Air Flight 610 crashed in Indonesia, killing all 189 people on board. Less than 5 months later, on March 10, 2019, Ethiopian Airlines Flight 302 crashed, claiming another 157 lives. These tragedies led to the global grounding of the entire 737 MAX fleet in March 2019. So the impact of the crisis reached a wide range of stakeholders. The most tragic impact was felt by the 346 victims and their families across the globe. The flying public lost trust in both Boeing and the FAA. Within the company, engineers and whistleblowers faced retaliation for raising safety concerns. Economically, airlines suffered billions in losses, and Boeing itself faced a shattered reputation. A $2.5 billion settlement within the Department of Justice and the eventual ousting of Muhlenberg in late 2019 are some of the losses. For my reflection, upon analyzing the leadership of Dennis Muhlenberg, I realized it has framed deeply how I view my own past in the engineering field. It is sobering to realize that even a highly skilled engineer can lose their ethical compass when faced with immense corporate pressure and financial targets. This case has taught me that my technical degree is more than a credential for a job. It is a commitment to serve as a guardian of public safety. In my future career, I want to lead with a transparency that was so tragically missing at the Boeing. This means having the integrity to communicate technical risks clearly to all stakeholders, even when it's uncomfortable or threatens a project's timeline. I've learned that true leadership isn't about moving as fast as possible to beat a competitor. It's about having the courage to halt a process when safety is at stake and ensuring that the human lives depending on my work always come before a company's bottom line.
Greetings, teachers and classmates. My name is Dwight Bussett, and I'm presenting the slides on ethics. This is Engineering Ethics Under Fire. It examines the ethical dilemmas faced by Boeing CEO that prioritized speed and profit over safety and resulted in lives lost. The core engineering ethical dilemmas faced by Boeing is safety versus cost, confidentiality versus public welfare, conflict of interest, environmental impact, ethical leadership, sign-off responsibility. They came about as a result of Boeing sacrificing safety versus cost. Examples of this is production pressure. They failed to comply with quality control requirements. They were losing money anytime they had to retrain a new pilot. They wanted them to minimize designs in this new Boeing jet. And plus there was MCAS concealment. They kept the MCAS training system out of the manual. It was originally used for fighter jets and they kept this out of the domain of the pilots also. And there's information control in company. They ignored warnings that the angle of attack could make the MCAS go faulty. They suppressed analysis from FAA, who said, well, one accident would happen every 15 years if they don't fix the bone design. And then regulatory delegation. The leadership failures also brought about this cascade of ethics, right? Management ignorance. A test pilot said that the MCAS was hard to handle, and they ignored that idea. Blaming pilots. After the second crash, they blamed the pilots' inexperience, saying, well, this happened to pilots from Ethiopia and Indonesia. It wouldn't happen to trained pilots like those from America. And then there's board conflict. The CEO and board member was Muhlenberg. He wasn't just the CEO alone. And these rules, it stopped it stopped independent governance of the company. The professional codes of ethics that were violated were National Academy of Engineering and AIAA Code of Ethics, both of which Dennis Muhlenberg is a part of, right? So in NAE, he failed to take corrective action known as MCAS issues. He blamed pilot training rather than acknowledging design flaws. He acted based on cost considerations while serving as a board member. He neglected professional conduct standards for aerospace systems. And then he violated the AIAA Code of Ethics in these ways. He did not prioritize public safety, health, and welfare. He harmed pilots' reputation through false blame. He presented data in a non-objective manner, which led to ignoring the AOA concerns. He failed to acknowledge and correct engineering errors. And in the slides coming up, we just expand on these points. One of the key takeaways of the ethics part of it is that public safety is paramount and you need independent oversight. Is this whole idea of delegation, as they call it, when they have people from Boeing as part of the regulators led to this incident also. Transparency saves lives because withholding the information and think people know something was up and Boeing suppresses information, and accountability matters. When these things happen, leadership must take responsibility for it. Thank you, classmates and teacher. Greeting teachers and students. While reflecting on the then Boeing CEO Dennis Muller, I came to the realization that ethics is more than about conscience, right or wrong, or who is a good person or a bad person. Ethics keep us in check, so there is no loss of life, no loss of property, no ruin of people's reputations. If the CEO, Mr. Muhlenberg, had kept to his ethics, 347 people would still be alive, and the way Bowen handled the situation would have been an example to other people. Instead, is an example of what a leader should not do. They shouldn't put money in front of people's lives. They shouldn't hide aspects of a product to make it look good. If they break something or they have knowledge about something broken and is within their power, they should fix it. And they shouldn't brush aside the expert opinion of their workers underneath them to meet a deadline. It makes sense now why every engineering organization have their own code of ethics to follow and why it's important to teach ethics to upcoming engineers. Thanks again, everyone.
Hello, good day. My name is Edson Williams, and I will be speaking on leadership decisions. Leadership decisions. The Boeing 737 MAX crisis. A case study in how executive choices under pressure can determine the fate of a company and hundreds of lives. Dennis Muhlenberg's tenure as CEO reveals critical lessons about prioritization, transparency, and the human cost of compromised safety protocols. Leadership at the helm. Dennis Muhlenberg's role. As CEO and chairman, Muhlenberg approved key engineering and operational decisions during the 737 MAX development and crisis response. So, because of his engineering background, there was a strong expectation that safety considerations would be central to his leadership. However, many of the decisions made under his leadership suggest that business priorities, such as maintaining competitiveness and meeting deadlines, were given significant weight. MCAS design approval. So, one of the most critical decisions made was the approval of the MCAS system design. MCAS, or the Maneuvering Characteristics Augmentation System, was intended to improve the aircraft's stability. However, it was approved with a single sensor dependency, meaning it relied on just one angle of attack sensor to function correctly. By not including multiple sensors or backup systems, an important layer of safety redundancy was removed. This significantly increased the risk of system failure. As a result, if the sensor provided incorrect data, the system could activate unnecessarily and repeatedly push the aircraft downward, which is exactly what happened in both crashes. So, decisions under pressure. So we would look at what Boeing did and what should have happened. So what Boeing did, they prioritized speed to market over thorough testing, limited testing timeframes to meet competitive deadlines, they continued operations after the first crash, and they skipped critical safety validation steps. So what should have happened? Comprehensive safety testing protocols should have been completed. The MCAS vulnerabilities should have been addressed before launch. Operations should have been suspended immediately after the first incident, and redundant sensor systems should have been implemented. The rush to compete with Airbus resulted in compromised safety standards. Leadership chose marketing positioning over methodical engineering validation. The devastating impact. Catastrophic failure of engineering judgment and ethical leadership led to a total of 346 lives lost, which included pilots, crew, and passengers across the two fatal crashes. There was also a financial impact of upwards of $20 billion, which included costs from crashes, grounding, lawsuits, and settlements. Withholding critical safety information from pilots and regulators had devastating consequences. The lack of transparency eroded trust and cost hundreds of lives. Leadership failed to ensure pilots understood MCAS systems or that regulators received complete safety assessments. The result? Preventable tragedies with lasting reputational and financial damage. Thinking on the engineering leader that we studied, along with all the cases we explored, such as the leadership roles in the movie Eye in the Sky, the AI and dark web cases, the Sam Bankman-Fried and Nelson Mandela cases, etc. It changed how I think about leaders and responsibility as a student pursuing engineering. I would have viewed leadership as being able to also make decisions or managing situations. But after reflecting on the case with Dennis Muhlenberg and the different cases we looked at in our class sessions, leadership seemed more about values, judgment, and the willingness to make difficult decisions, especially when people's safety is involved. One of the biggest things that really came out to me was how leadership failures are ethical and technical. The decisions made were not necessarily due to a lack of knowledge, but more a failure to put safety, transparency, and accountability first. This is linked strongly to what we learn about professional responsibility in class, and where engineers or leaders are expected to protect the public and talk up or speak up when something is wrong, especially when they are under pressure. It also made me think of the importance of values-based leadership. So, from our ethics and professionalism sessions, we saw that the effective leaders were not just defined by authority or the skill set that they had, but by their character and the traits that they demonstrated, and also the values that they portrayed. So, in the case of the Boeing 737 MAX crisis, the absence of strong ethical leadership led to disastrous consequences, which resulted in many deaths and a lot of financial losses. Decisions such as approving a system with limited redundancy and not acting quickly after the first crash showed how critical ethical responsibility is. At the same time, while looking at another case that we did recently in class, the Chilean miners, it showed that true leadership is about putting others first and remaining calm under pressure and guiding people through difficult situations. So those two differences, along with others that we did in class, really helped me understand what good leadership is supposed to be. So moving forward, this changed how I see my role and even others' role as a professional in society or as a budding professional. And I understand that I have a responsibility not just to do the job that is given to me well, but to uphold integrity, to be honest, and prioritize safety above all else. It also means to me being willing to challenge these decisions if they put people at risk, even if it is uncomfortable. So, of all the cases we reviewed and the different things we discussed in class, it helped show me that engineering really about, isn't mainly about building systems, but making decisions that affect lives. And because of that, responsibility and other ethical values aren't merely optional, but they are essential in the community.
Hi, my name is Josan Mansugi, and I will be exploring the outcomes and impact of our case study, Boeing 737 MAX crisis. So, from a research standpoint, we see that this crisis involving Boeing 737 MAX, it provides a critical example of how simple engineering leadership decisions can actually shape outcomes via safety, organizational integrity, and also public trust. Public safety, the human cost. Something that we cannot change is that 346 lives were lost because of these tragedies. We had the Lion Air Flight 610 and also Ethiopian Airlines Flight 302. These are scars and memories that we cannot forget. Investigations revealed that the MCAS system, software designed to actually improve aircraft handling, was triggered by faulty sensor data and repeatedly forced the aircraft detrimentally to go nose downward. Three key things that came out of this: inadequate communication, key ethical failure where MCAS functionality was not adequately communicated to pilots. Here we have pilots that were trained in a particular way, working on particular aircrafts, and we have this new system that was not even presented to them, and they weren't even trained on how to use it. So we had insufficient training, where leadership decisions to minimize additional pilot training to maintain market competitiveness. Business versus safety. There was a clear conflict between business priorities and the fundamental engineering duty to protect human life. Impact on employees. Many Boeing engineers had raised concerns about safety, but these were not effectively addressed. This indicates a weak ethical culture where employees may have felt unable to speak up freely. As a result, workers experience stress, loss of trust in leadership, and reputational damage from being associated with the crisis. They also had breakdown in culture, increased scrutiny, pressure to compromise, and as said before, internal concerns were ignored. Moral injury, the psychological tool. It takes a lot of maturity and courage to go against the status quo, to go against the big CEOs. And these engineers in Boeing experienced moral injury. They went through a lot of psychological distress resulting from actions or inactions that violate their ethical code. They were directed to downplay MCAS to the FAA or avoid pilots simulating training requirements, forced technical staff to compromise the engineering rigor that was once their professional hallmark. When we talk about the 737 MAX, there were many consequences that came out of these decisions that were made. Consequences like localized environmental damage. The crashes involved aircraft debris and fuel spillage at crash sites. Fleet grounding impact, where grounding of the global 737 MAX fleet led to operational inefficiencies and increased fuel consumption from substitute aircraft. There were a lot of industry disruptions across the aviation industry, reflecting how engineering failures can ripple into broader systematic inefficiencies. I think the best explanation that I came across for this Boeing research is a tale of two cultures, where one culture is an example of good engineering culture. It supports innovation and growth and gaining the trust of clients, where the culture shift that happened in Boeing was a lack of innovation. It was a different type of competitiveness, only thinking about increasing stock and going up in costs and cost cutting on things like training and things that really built Boeing. It's unfortunate that all of these things had to happen and all of these lives had to be lost before we really come to our senses on what is leadership, and for something as important as getting to a place A to B, or places A to B, getting from Trinidad to Miami, we would have all flown on one of these planes at some point in time, and no one has to feel like a flight is their last flight, or have the burden of losing a family member due to a plane crash. So it's a case study and we learn from it. We learn that certain aspects in engineering, especially when it comes to safety, should not be compromised. And we learn that it's okay to speak out, to go further, and to really stand your ground as an engineer or an employee in a company where you feel like things are not going right ethically. So that's my take. Thank you.
Good day, my name is Daniel Budu and I will be presenting the second half of point number 4, Outcomes and Impact. Now we'll look into organizational reputation. This crisis did tremendous damage to Boeing's global brand. The corporation was formally recognized as a leader in safety and engineering excellence. Where public criticism was directed at the lack of transparency and delayed responses, the aircrafts were grounded for nearly 2 years around the world, costing billions of dollars and causing airlines and customers to lose trust. Boeing's chief technical pilot admitted to using a Jedi mind trick to mislead regulators about the MCAS system. Instead of using his technical expertise to ensure safety, he used it to manipulate the approval process, a serious betrayal of the ethical responsibility engineers hold. Because the crashes were partially caused by an automated system, pilots could not override. The public lost interest in machine-driven decision-making. This Boeing effect has made it harder for other industries like self-driving cars to gain public acceptance for AI in safety-critical roles, even when the technology itself is reliable. Finally, we'll look into public trust. The public trust in engineering and regulation was deeply affected. Faith in the aviation safety systems decreased, particularly in the Federal Aviation Administration's certification procedure. The scandal generated questions about whether firms wield undue influence over their own safety approvals. As a result, tighter laws and control mechanisms were implemented globally. The Boeing 737 MAX disaster highlights how poor leadership and a flawed company culture can be just as responsible for engineering failures as technical errors. Decisions driven by budget pressures, market competition with Airbus, and shortcuts in the certification process ultimately cost lives. This case is a powerful lesson that ignoring safety in favor of speed and profit doesn't just cause immediate harm. It erodes public confidence and forces sweeping changes to regulations across the entire industry. My response to the question, reflecting on the engineering leader you studied, how has this analysis shaped your own understanding of ethical responsibility and leadership in your future engineering career? The 737 MAX crisis under Muhlenberg's leadership reminded me that engineering is a profession with real human consequences. Safety should never be sacrificed to meet deadlines or save money. The way he protected Boeing's image instead of being honest, even after hundreds of people died, showed me what bad leadership looks like. The fact that engineers inside Boeing had worries but felt they could not speak up also taught me that doing the right thing is not just about personal choices. It is also about creating a workplace where people feel safe to raise concerns. As a future engineer, I want to always speak up when something seems wrong, take responsibility for the impact of my work, and never let pressure from others push me into making decisions that could put lives at risk. Thank you.
My name is Farid Baksh, and for this section, I will be presenting the key lessons the engineering profession can learn from the Boeing 737 MAX crisis and propose practical, ethical, leadership, and organizational strategies to prevent similar failures or improve future crisis response. These points will also be directly linked to the IET Code of Conduct. The first lesson we would look at is protecting people above all. One key lesson that engineering leadership must always prioritize public safety above business objectives such as profit, deadlines, and reputation. From our sessions on leadership, we learned that leaders must not only serve but protect people as well. In this case, production pressure and competition both influenced the decisions that affected safety. This directly aligns with the IET requirement to act in the public interest and protect the safety of the public. The recommendation for this lesson would be organizations should implement a safety-first leadership structure where engineering leaders have the authority to delay or stop operations if safety is uncertain. Leaders should be courageous to not conform to organizational pressure, but instead be able to challenge it when necessary. Another important lesson is that integrity is the foundation of engineering practice. From our session on integrity, we looked at the case study of the safe bridge infrastructure dilemma and discussed the importance of a do-no-harm mindset, even if it damages business interests. The lack of full transparency on Boeing's part about the MCAS system reflects a breakdown in ethical responsibility. This aligns with the IET requirement to be honest, trustworthy, and open. The recommendation would be companies must enforce full transparency in design, communication, and reporting of all safety critical systems. Also, encourage leaders to adopt a do-no-harm mindset. Lesson 3. Leaders must be able to anticipate risk and consequences. From our sessions, we looked at and discussed the leadership style of Colonel Catherine Powell from the film The Eye in the Sky, where we saw that effective leaders think ahead and anticipate possible outcomes. In this crisis, worst-case scenarios were not fully accounted for, such as a sensor failure or pilot response. There was no strategic thinking in asking key questions such as what can go wrong or what is the worst possible outcome. This aligns with the IET principle of exercising due care, competence, and diligence. The recommendation would be organizations should implement advanced or rigorous risk analysis and scenario planning. Lesson 4. Accountability cannot be avoided. A lesson that leaders must take full responsibility for their decisions. In this case, accountability was delayed, which worsened the crisis. Boeing initially blamed external factors and continued operations after the first crash, instead of addressing possible design flaws. The real responsibility and action only came after the second crash, where there was increased global pressure and eventually led to the resignation of the CEO Dennis Muhlenberg. This aligns with the IET requirement to accept responsibility for decisions and their consequences. The recommendation: clear accountability structures should be established at leadership levels, and leaders should be evaluated based on ethical and safety performance as well. Culture shapes behavior. Our class sessions highlighted that people are shaped by their environment. The issue here is there was a culture focused on cost and speedy engineering decisions, which suppressed ethical concerns in this case. This aligns with the IET principle of promoting ethical conduct. Solution or recommendation: organizations must develop a strong, safety-oriented culture that encourages open communication, ethical decision-making, and respect for engineering judgment. Lesson 6. Engineers must speak up. Leaders must empower and support their team to raise concerns without fear. If people are unable or afraid to speak up, risks may go unaddressed. This aligns with the IET requirement to raise concerns about risk and unethical practices. A recommendation for this would be companies should implement strong whistleblower protections and reporting systems where they know that they are protected and can raise any issue without fear of discrimination or termination. Lesson 7. Global impact, global responsibility. The Boeing crisis demonstrates that engineering decisions can have global consequences. It showed that failures in one aircraft design affected passengers, airlines, and regulators across multiple countries, not just one region alone. It also damaged global trust in aviation systems and forced worldwide changes in safety regulations and oversight. This aligns with the IET principle of considering the wider impact on society and environment. A recommendation for this would be engineering projects should include global risk assessments and consider diverse operating environments for worldwide consequences. Another key lesson from this case is that advanced technology can become dangerous if it is not properly controlled. The final lesson is that public trust and professional competence are essential in engineering. Trust and continuous learning. The crisis damaged trust in both the organization and the profession, and also showed the importance of fully understanding complex systems. It shows us that trust takes years to build, but can be lost in 1 second. This aligns with the IET principles of maintaining public confidence and ensuring continuous professional development. The recommendation would be never stop learning. Leaders must always stay updated with effective technology. Effective engineering leaders must combine technical knowledge with moral courage, ensuring that safety, transparency, and accountability remain at the core of every decision. In conclusion, the Boeing 737 MAX crisis highlights that engineering failures are not only technical, but also ethical and leadership failures. By applying the lessons of safety, integrity, accountability, and transparency, all aligned with our course sessions and the IET Code of Conduct, the engineering profession can prevent similar crises and improve future decision making. Once again, my name is Farid Baksh, And this is my personal reflection response. So, reflecting on the leadership shown during this crisis, the analysis has shaped and further reinforced my understanding of ethical responsibility and leadership in my career. I realized that being an engineer is not just about technical competence, but also about making decisions that directly affect human lives. I see the importance of safety in order to protect human lives and the environment, even where there's pressure from costs, deadlines, or even competition. The case has showed me how critical integrity and transparency are, how withholding information or even delaying action can have serious consequences. I understand that I must always be honest and accountable for my decisions. It also highlighted the importance of thinking ahead, anticipating risks, questioning assumptions, and even considering worst-case scenarios before implementing any system. Another key takeaway for me is that the role of leadership in shaping culture, the importance of it. Your team must feel comfortable and empowered to speak up when something is wrong. They need to feel that they are supported by their leader and not be afraid of you. Right? I know that to me, leadership means creating an environment where safety concerns are taken seriously and always acted upon. This is an environment that I myself as a leader always try to create wherever I am. And overall, the analysis has reinforced to me that ethical engineering requires courage. The courage to prioritize public safety, to even challenge decisions when necessary, and to take responsibilities for the outcome. In my career, I try to uphold these values and ensure that my work contributes positively to society and maintains trust and quality in my profession.